So good morning all of you. The summary of the last lecture, we have discussed this crystal structures and interplanar separation. This is what we have done. So let us solve some problems from the crystal structures, and after that we will go to reciprocal lattice. Okay, now write down. This was the June 2008 CSIR. Let us solve some questions from CSIR and JEST. First question. Hard disk, HARD, hard disk of radius capital R, hard disks, DISCS plural, hard disks of radius R are arranged in a 2D triangular lattice, in a 2D triangular lattice, full stop. What is the fractional area? Means he is asking packing fraction. What is the fractional area occupied by the disks, in the closest possible packing. Once again I request you, please read the question one more time. Hard disks of radius capital R are arranged in a 2D triangular lattice. Okay, what is the fractional area? Fractional area means what he is asking, packing fraction. But why he specified area? It's a 2D lattice. You won't get volume now, you will get what? Area. Okay, fractional area occupied by the disks. So the disks are occupying the area in closest possible way. Packing, closest possible packing. Ready? Right. So all of you please listen. Here we have a disk of radius capital R. Okay. So everyone please listen carefully. We have a disk of radius capital R, and here we are arranging all these disks like this. Oh. So we are arranging the disks such that it is the closest possible way. That means minimum it should enclose one atom. That is the meaning of a closest possible way. It should enclose at least one circle, one disk. If you see carefully, this is the closest possible way. Why? It is enclosing one disk or one atom, whatever it is. So at each center we have a lattice point. Is it clear? Now if you observe carefully, sir, where is the triangular lattice? See carefully, you have triangular lattice. That's it. Now this become what? Unit cell. This is the unit cell. Now because it is enclosing a minimum one atom, so this is what? Unit cell. This unit cell is a combination of how many triangles? 1, 2, 3, 4, 5, 6. So your unit cell is a combination of how many equilateral triangles? 6. Is that clear? Just imagine each disk is an atom. Okay, is that clear? Are you listening? So that's it. He is asking the minimum or the closest packing. Closest packing means at least one atom should be enclosed. One disk must be enclosed. Okay, so this is R and this is R. We can say this is nothing but A. So A equal to how much? 2R. That's good. And here we have unit cell. Now could you please tell me what is this unit cell? It's a unit cell is a hexagon. How many triangles are there? 6 equilateral triangles. That's good. Now let me find the area of unit cell. I am finding the area of unit cell. Everybody, it's a triangle, equilateral triangle, root 3 by 4 a square. Like this, how many are there? Now, a equal to how much? That's why. So, very simple, no need to get tension. Root 3 by 4, your a is nothing but 2r whole square. This is the area of a unit cell. If you want to find the packing fraction, first you need that denominator, area of the unit cell. Earlier 3 dimension you have volume, because it is a 2 dimension, that's why we are finding. Next thing, what do you want? Number of lattice points or number of atoms. Number of atoms in unit cell. Listen, very easy. I told you one small technique. Whenever it is a 2 dimension plane or something, take the angle by total angle. Ready? So your unit cell is a hexagon. Yes, now, please go to the one atom. I hope you are observing. This is the sharing of one atom. Say yes or no? Now, what is the sharing? The sharing is, I hope everybody know this angle is 120 by 360. Already I explained this technique. How much? In this hexagon, how many atoms are there? 1, 2, 3, 4, 5, 6. 6 atoms sharing. In the middle. That's why number of atoms per unit cell. 6 are having sharing. In the middle. So answer. Any trouble up to this? Now we are finding the packing fraction, n into area occupied. I am not writing volume because it is a 2 dimension, by area of a unit cell. So n you got how much? 3. Area occupied, it is a disk. Say yes or no? Right. The disk area is how much? That's good. By area of the unit cell. 6 root 3 by 4 into 4r square. R square, 4, and the answer I think it is root 3 pi by 2. Check. Is it okay? This is 3, root 3, root 3, root 3, root 3 cancel, root 3 by 6. Root 3 by 6 is what? Pi by? 2? Correct. Pi by 2 root 3. That's it. That is the answer. Clear? Right up. Take the options also because the CSIR question. Here is a small twist. This is given in the June. Exam is given in the June. Before June, February, there is a JEST exam. In JEST exam, one question is given. I will explain the next question. See how they will frame the question, you will understand. Please underline that closest packing possible. What is that word? Closest possible packing. Underline that word. That means at least one atom must be enclosed. That is the minimum possible way. Just you have to imagine the diagram, and after that get the sharing, and you got the unit cell of 6 equilateral triangles. I got the area and the number of atoms per unit cell, you know how to find. After that your packing fraction is ready. So where is the answer, Amma? Pi root 3 by 6 is the answer. Oh, first one. CSIR given this answer, just given this answer. That's why solving previous papers before going to exam is very important. That you should not do now, you have to do before going to the exam. Maybe after going back you may have 1 or 2 months time, so don't neglect, please keep on practice. In hurry, sometimes what we will do na, the exam, you got the answer pi by 2 root 3. Then you will search for the options. Okay, you will see only pi by 2. Yeah, in a hurry what you will do, you will see only pi by 2 root 2, pi by 2 root, pi by 2 root, come on, A, B. But be careful, after doing 6 months work, you are getting this mark. Don't lose it easily. Next problem. Although next one is the similar problem, but do it again just for practice. But the framing of the question is different. Write down. Second problem. Is it over? A flat surface is covered with non-overlapping discs of same size. Non-overlapping, that means you have to just make them touch with each other. So non-overlapping of discs of same size, full stop. What is the largest fraction? What is the largest fraction of the area that can be covered They didn't give any diagram. You have to imagine. By reading the question, you have to get that idea. What is that? Once again, please read the question. So, a flat surface is covered with non-overlapping of discs. Write it. 1 minute. So, try to draw it yourself. Take one disc in the middle, above one disc, and side one disc. Come on, do it. You should draw a little bit careful, then only you will get the proper diagram, otherwise no. Oh, I got like this. It's okay, you please draw yourself. Similar diagram. Quite similar diagram, whatever earlier you have drawn. Do the same problem again one more time. Getting sphere difficult. Oh, I got an idea. You know that it is a hexagon, right? That's better. Right, at least draw now. crystallography, all crystallography problems are geometrical problems only. Do it carefully, don't neglect. 5 marks. A similar concept, come and do it. Again 6 triangles, equilateral triangles. Find the area of the unit cell. Find the number of atoms per unit cell. And write the packing fraction formula. Don't see above. Please do it yourself. You should get the same answer. Please check. Do it one more time for practice. The same answer. I think you got 6 equilateral triangles there also, and area is this much, and the number of atoms, you know, the angle is 120 by 360, that is 1 by 3 into 6 are there, and the middle one is there 3. So that's why 3 into area of the disk by area of the unit cell, that is pi by 2 root 3. Over. Now see the twist. Next again JEST. Because much more questions won't be available in the SSP. That's why they will change, keep on changing the same question here and there. Write down. Circular disk, again JEST. Circular disk of radius 1 meter, of radius 1 meter, of radius 1 meter each, of radius 1 meter each, placed on a plane, placed on a plane, placed on a plane, so as to form a closely packed, to form a closely packed triangular lattices, to form a closely packed triangular lattices, triangular lattices, full stop. The number of disks per unit area is approximately, the number of disks per unit area is approximately A, option A, please write down. Ready. So what he is asking, number of disks per unit area. Are you interested? A face length, let's just wake up and came to the class. Right. See, here we have a triangle. So in this triangle, how many atoms are there? 3. He is asking what? Number of disks per unit area. Then you need not to take total unit cell. Earlier packing fraction is there, that's why we have taken total unit cell. Here you need not to take a unit cell. Simply what he is asking? Number density. Are you ready? Wait. So this is the radius and this is also radius, and this is the side of the equilateral triangle. First I have to get the area. Area of the equilateral triangle how much? Root 3 by 4 a square. That is root 3 by 4. A is 4r square. So 4 gets cancelled. That's why area equal to. That's what I am saying. Are you interested? Means you are not knowing what you have written in your notebook. What is the radius given? It's a waste to discuss. So still you don't know what you have written with your hands. Okay, this is the area. So once you got the area, he is asking simply number of atoms per unit area. Now ready. I told you how to get the number of atoms. Sharing. So what is the sharing? Good. 60 degree by 360. Very nice. Sit down. 1 by 6. So the number of atoms. She said sharing is how much? 1 by 6. How many are there? 3. That's why 1 by 2. So finally the answer is number of atoms per unit area. How many atoms we got? 1 by 2. What is the area? Root 3 meter. So 1 by 2 root 3. Check. Three questions based on a same concept. That is what I want to say. Anta? CM. If you want, you can take unit cell also. You will get the same answer. No need to take, because simply we are finding number density. Then no need to go for unit cell. Triangle is enough. I have given radius is 1 meter. So 1 by 2 root 3 means I think the answer is a C. Next problem, again CSIR. Ready? Yeah? Write down. Next one. Consider the crystal structure of NaCl. Consider the crystal structure of NaCl. Consider the crystal structure of NaCl, which is modeled, MODELED, modeled as a set of touching spheres, comma, structure of NaCl which is modeled as a set of touching spheres, comma, each Na atom, CSR question amma, each Na atom has radius r1, has radius r1, has radius r1. Next, comma, each Cl atom, each Cl atom, each Cl atom has radius r2, has radius r2, has radius r2, has radius r2, small r2, full stop, small r1, small r2, anything you can take, full stop. The centers of sphere, the centers of spheres form simple cubic. Now you will understand how many are studying seriously. Which cubic structure? Did you remember all the properties of simple cubic? Sure, pakka. If you know that, you will get 5 marks, otherwise no. What is the packing fraction of simple cubic? Pi by? Abbo. ఎవరు చెప్పరు, ఐ వాంట్ టు వెళ్ళిపోదాం అనుకున్నాను, అందరు చెప్పేశారే. కమ్ ఆన్, రైట్ డౌన్. గుడ్. సెంటర్స్ ఆఫ్ స్పియర్స్, వెరీ గుడ్, యు ఆర్ స్టడీయింగ్. ద సెంటర్స్ ఆఫ్ ది స్పియర్స్ ఫార్మ్ ఏ సింపుల్ క్యూబిక్, full stop. The packing fraction is, the packing fraction is, write the options, please write the options. Focus on problems. Theory everywhere you will get in the books, but you will get the problems only in the CSIR, 5 marks. But don't think too much, all problems are very easy in SSP, but so calm and understand the question given. Right, listen. So here NaCl structure is given, and he is saying that it's are touching spheres, and all centers of the spheres are forming which structure? Simple cubic. You said earlier, simple cubic structure packing fraction is how much? Pi by? Now he is asking which of the following is the packing fraction for that NaCl. But Na radius is what? But Na radius is R1, Cl radius is R2, but simple cubic R1 is equal to R2. So one of the answer gives you pi by 6 if you keep R1 equal to R2. Check. By seeing that you will get so much tension, what is this, how to derive? But a small factor, underline that simple cubic, underline that simple cubic. Check one by one answer by taking simple cubic R1 equal to R2, then packing fraction must be pi by 6. Which one? Check one by one. Second option, whatever it is, second, okay. I think first one, how much you are getting? Pi by? Oh, this is giving pi by 4, that's why wrong. So this is giving pi by 6, that's why right. Now get ready. So this is the most important part, and take a fresh page and put the heading Reciprocal Lattice. First let me convince you what is this reciprocal lattice and why we are choosing this and what is the purpose of this. First let me explain. Take a fresh page, put the heading Reciprocal Lattice. You tell me one thing, why you are studying crystal structures? To get the marks in SSP. Properties of material. Now you have this solid. I want to know these properties. What you will do? You have a material, I have given a material. You want to know the properties of the material. What you will do immediately? You will send some particles, some EM waves, some X-rays. Is it okay? Right. So first I am sending a EM wave, X-ray or whatever it is, I am sending some EM wave. What you are sending? EM wave. This is the solid. Till now what we have discussed is, every solid is having some crystal structure, simple cubic, BCC, FCC, base center, hexagonal, and diamond structure is what? Diamond structure is 2 FCCs. Combination of 2 FCCs, one is at the center 0, 0, 0, another is at 1 by 4, 1 by 4, 1 by 4. Simply if anybody asks what is a diamond structure, please explain. Just tell them, take FCC, You know what is FCC? Okay, FCC means what? 8 corners and 6 face center. After that, how many diagonals are there? 4. I know. How many body diagonals are there? 4. Body diagonals are 4. Now see that corner. Everyone see that bottom corner. You also please see the bottom corner of the room. You want to meeru kada calculate. Meeru chudandi. So that is the bottom corner. Bottom corner to that top corner. Bottom corner to opposite top corner. That is the body diagonal. Similarly, that top corner to this bottom. Similarly, bottom to top, top to bottom. Total how many are there? 4 body diagonals are there. Now listen carefully. This is the typical structure. So diamond structure, how to visualize means, take FCC. I hope everybody now got what is FCC. After that take 4 body diagonals. Now start from this bottom diagonal, bottom to top. From this bottom, I will take one more carbon atom at 1 by 4. 1 by 4. Along the same body diagonal, one more atom at 3 by 4. Means from there it is 1 by 4. Again, one more body diagonal here. Is that clear? 1 minute. Here you have 2 body diagonals. On one diagonal, 1 atom. Another diagonal, 1 atom. Total how many are there? 2. Next again. This side how many diagonals are there? 2. Again same. On one diagonal, 1 carbon atom. Another diagonal, 1 carbon atom. One diagonal is at 1 by 4. Another diagonal at 3 by 4. That's why if you see the structure, they will write 1 by 4, 3 by 4, 1 by 4, 3 by 4 like that. That means one body diagonal 1 by 4, another body diagonal 3 by 4 means from that side it is 1 by 4. Is that clear? And here 2 diagonals, on one diagonal 1 by 4, another diagonal from that side 1 by 4. That's why you will say 2 face centers 0, 0, 0, 1 by 4, 1 by 4, 1 by 4. That's it. If anybody asks what is the diamond crystal structure in interviews, just tell them it's a face centered cubic plus 4 extra carbon atoms along the 4 body diagonals kept at 1 by 4, 3 by 4, 1 by 4, 3 by 4. Then they will understand what is the meaning of those things. Okay, good. Ready. So now we have been given some solid, some crystal, and we want to know the properties of this. Then what you are doing? You are sending an electromagnetic wave. X-ray is electromagnetic wave, na? You are sending wave, but this is what? Geometry, direct lattice. What you are having? points, planes you are having. Am I right? This is just having a translational symmetry. How you are getting a lattice? Lattice, an infinite array of points by translation vector. That means what symmetry you are using? Simply you are placing the points. Any wave nature here? You are sending a wave to go and interact with points. Some logic is missing. The reason is, if a wave nature is interacting with the wave nature, then you can study more easily how the diffraction occurs, how reflection occurs. That's why I hope now you understand the whole basic idea of reciprocal lattice is, I am sending a wave, but this is having translational symmetry. That means it's just simply array of points, not having any wave nature. If suppose, if possible, if I am able to represent this entire direct lattice with a set of wave vectors, then a wave is interacting with the wave. Then I can easily study how the reflection is going on, how the diffraction is going on. So, whatever the direct lattice you are having, corresponding to that direct lattice, we are going to construct a reciprocal lattice. So, now reciprocal lattice contains what? A set of wave vectors. Each point gives you, or each vector gives you a plane wave. Say yes or no? If there is a k1, what is a plane vector? E power I k1 dot r. K2 bar is there. E raised to I k2 bar dot r. That's a plane wave. So then your EM wave is interacting with what? Again wave nature. Are you understanding? Say yes or no? Wait. Now let me take the definition again, still not understanding. A set of, I will explain once again. A set of wave vectors. A set of wave vectors, that is the k bar, that yields plane waves, plane wave. I hope you know what is this plane wave, why I have written here e raised to I k bar dot r bar. Each vector is having a one plane wave. Once again, a set of wave vectors that yields plane wave which has the periodic behavior, of direct lattice, This is very crucial. Simply not writing e power I k bar dot r bar or simply representing with a k bar, that should satisfy. Some translation symmetry is there. So that translation symmetry is giving you what? Periodic behavior. So that wave vector should have that periodic behavior. I will explain what is that. Just wait. Amma, generally, what is our task? What is our study? We are using this X-rays, a beam of X-rays. If you want to read, you have to read 2-3 pages. Please listen. Within 10-15 minutes, you will understand what exactly it is. And here I have a direct lattice. After that, please read, no problem. So this is array of points with the help of translational vectors. That's why this is my direct lattice. Which is having which symmetry? Good. Translational symmetry. Right. Now what is the problem here? It's a simply array of points. I'm not getting any information from this. So this is simply a set of translational vector. I'm writing it as r bar. R for real. Okay, good. So everybody know, instead of t, I'm using r bar. n1 a1 bar plus n2 a2 bar plus n3 a3 bar, where a1, a2, a3 are primitive vectors of the direct lattice. Now the basic idea is, here I am sending a wave. Why don't you assign wave nature to this lattice? Is it possible or not? Then the mathematicians started working on this. Yes, it is possible. These are set of points. Every point I can make a Fourier transform. Then once I make a Fourier transform, what I will get? A reciprocal lattice. A set of k vectors. A set of, you know, psi of x is a transform to psi of k. That means x is a transform to k. Understand? So we are taking the help of. That's it. That's it. Set question, amma. Fourier transform. Then what I get? Set of k vectors. Super. I got some set of k vectors, but listen. Cool. So this is corresponding to 1k, like that. Okay. Each point yield e raised to I k bar dot r bar. That is the first point. Over. Ready? Next, he has said something. Periodic behavior of or Brillouin lattice. Brillouin lattice is nothing but direct lattice. Any word you can use. What is that periodic behavior? Everybody, are you observing the board? E raised to I k bar. You said that plane wave should have periodic behavior. That should have k bar dot r bar plus capital R bar must be equal to e raised to. That's it. That is the periodic behavior. What you have added? Of direct lattice. R bar vector of direct lattice. Is that clear? Ma, this is the meaning. I hope everybody understand what is the meaning of this definition. A set of wave vectors k yields a plane wave. Each point represents a plane wave, and that plane wave should have the periodic behavior. This is the periodic behavior. Everyone see. E raised to I k bar dot r bar e raised to I k bar dot capital R bar equal to. Shall I cancel these two? Then e raised to I k bar dot r bar equal to 1 can be written as. That's why, come on, say. The dot product of real vector and reciprocal vector is equal to 2 pi. We will derive again, don't get tension. Just from the periodic behavior, this is the property. Whatever the wave vector you are using, that vector and real vector, corresponding real vector dot product should be equal to that only. Then only we have to use that reciprocal lattice. And this is the relation between. So simply taking k vectors, this is the reciprocal lattice, we cannot say. That should satisfy this condition. K bar dot r bar equal to 2. Everybody understand up to this? I got a doubt. Ready? Why you are using this? You can study with the direct lattice now. You can study with the direct lattice now. Why again you are introducing this reciprocal lattice? Wave nature. Okay, one condition I said wave nature. Any other? Think. Say properly. Stand and say properly. All properties of material. We won't get all properties of material. Now see, this this is the direct lattice. Everyone see the board. This is the direct lattice. Direct lattice means what? This entire space is filled with these boxes. Say yes or no? Then it is become a solid. Can you please tell me what is this plane? Take any axis, x axis or y axis. Take x axis. 1, 0, 0. This one. If this is 1, 0, 0, what is this? 1, 0? Why? Set of parallel planes. This is a 1, 0, 0 and this is also again one more plane, one more plane, one more plane, like that. How many planes are there? Now, if you consider a direct lattice, you have to consider all these parallel planes, because the wave is interacting with the one of the parallel plane. So, which plane it is interacting? Then we have to study each and every ఒరే నీకంటే నేను పెద్ద యాక్టర్ రా బాబు దరిద్రుడు. So you have infinite number of parallel planes. This fellow and that fellow sometimes sleep in the class. This idiot and that idiot. So they think that he don't know. I know everybody what they will do. But ready. So these are parallel planes. Like this, infinite number of parallel planes are there. All these infinite number of parallel planes, it's very difficult to study the wave which is interacting with what plane. Now the idea is, they thought, hey, all these parallel planes, can we represent with a single point? The answer is yes. That single point is nothing but your reciprocal lattice point. The beauty of reciprocal lattice point is each point represent a set of all parallel planes. 1 minute. So, each reciprocal lattice points represent, I am not giving any points, everything I am writing here, represent a set of parallel planes of direct lattice. That's good. Fine. Then how to represent? Good question. Ready? So what you are saying is each point represent. Now I am taking a parallel planes, a set of parallel planes. Babu, please concentrate. If you want to understand later, although you have seen 10 videos, you won't understand. Listen please. All these are set of parallel planes and interplanar separation is what? D, H, K, L. All these parallel planes are represented by a Miller indices. What is that? HKL. HKL. Now, I am taking, see the board, I am taking a normal to the plane. All the planes, normal to all the planes. So this is a normal drawn to the set of parallel planes. This normal is passing through one of the lattice point. That means this normal is passing through one of the reciprocal lattice point. And this vector is called G bar. Reciprocal lattice vector. Now, how to visualize the reciprocal lattice vector of a simple cubic? Take a simple cubic, take this plane and take this plane. Now take a normal to all these planes. Okay, this is the normal. So this represents a reciprocal lattice vector corresponding to perpendicular to 100 planes. You can take any planes like that, a set of parallel planes and draw a normal. That each normal represent what? Reciprocal. reciprocal lattice vector. That reciprocal lattice vector G bar equal to H B1 bar, because you are representing with all these parallel planes with a Miller indices, H B1 bar plus K B2 bar plus L B3 bar. That's it. So, if I have a set of parallel planes in the direct lattice, all those planes are represented by a single reciprocal lattice vector, that is H B1 bar plus K B2 bar plus L. That B1, B2, B3 corresponds to reciprocal lattice vector. I will explain how to find. If I have 1, 0, 0 planes, 1, this is 0, this is 0. I have double 1, 0, 1, 1, 0. Like that you will get the reciprocal lattice construction. You understand from this? So once again, please see. So what is a reciprocal lattice? It's simply a set of right. So what is this reciprocal? From where you missed, Amma? Please take the mic and say from where you have missed, Amma.
From the starting point.
From the starting, ayyo. Okay. Right. You please start writing. So please listen. Right. Wait, please wait. Don't write, ma, calculate, just wait. You please write. And calculate, students, just wait. So reciprocal lattice vector and a direct lattice vector dot product should be always 2 pi. Some textbooks will take the 2 pi as a scaling factor and they will write it as a 1. And a 2 pi is a scaling factor, like that they will take. Nobody has seen screen? Then why didn't you inform? You tried. Please say, otherwise time will be waste. I have not given a chance. Huh? Now you please read about this reciprocal lattice in the Wahab book, and whatever the new points if you find, just write those things. But the main content I have given, what is the purpose and why we are doing and what are the properties, I will explain each and every one, don't worry. So reciprocal lattice, what we understand the definition, a set of wave vectors that yields a plane wave which has the periodic behavior of the direct lattice. That periodic behavior gives k bar dot r bar equal to 2 pi. This is the condition. So every k bar that corresponding r bar should satisfy this condition. That's the meaning of that. We are not discussing any crystal defects here. That I don't know. We will discuss in the crystal defects, but I don't know whether I will discuss the crystal defects or not. Ready? Yeah. If a crystal dislocation is there, in the reciprocal lattice also will be dislocated. Corresponding to that, the change will be there in the k bar also. Ready? Yeah. Stop. Now the reciprocal lattice construction. Here I have a direct lattice. Am I everybody? So here we have the real lattice. Very easy. Listen. A1 bar, A2 bar, and A3 bar. This is the x-axis, y, and z. So everybody know what is the volume of the real space? A1 bar dot A2 bar cross A3 bar. Or you can take A2 bar dot A1 bar cross A3. That you know, 3 terms are there. Triple product of vectors. Okay, so now I am going to construct the corresponding reciprocal space, the reciprocal lattice. If you want to get the reciprocal lattice vectors, first we have to write the primitive vectors. So here also we have the corresponding primitive vectors. This is B1 bar, B2 bar, and this is B3 bar. So a set of A1, A2, A3. we are getting here set of corresponding, everything is a corresponding, whatever the changes corresponding here also will be there. B1 bar, B2 bar, B3 bar. Simple definition summa, everyone please listen. B1 bar is defined as 2 pi into, what is this? 1. 1 after, 1 after A2, 2 after A3 by volume of direct lattice, volume of real space. What is the volume? A1 bar dot A2 bar cross A3. Is that clear? Next, come on, say yourself, B2 bar equal to any trouble? Now come on, say B3 bar equal to right. So to get more practice on this, okay, let us take the first one. I am taking simple cubic. Everyone please listen. Simple cubic. A1 bar equal to how much? A2 bar equal to how much? A3 bar equal to how much? Now I request you, please find B1 bar. 2 pi A2 bar cross A3 bar by volume. What is the volume of simple cubic? A into A into A cube. BCC volume is A cube by 2. FCC volume is A cube by 4. Okay, good. So 2 pi, A2 into A3, how much? By A square and this cancel. How much? 2 pi by? Ayo. 1 minute. Ready. So A2 cross A3, Y cap cross Z cap. So finally 2 pi by A. Since it is a reciprocal lattice, you got 1 by A. And 2 pi is called a scaling factor. 2 pi is called simply a scaling factor. That's why again you got AX is transformed to X cap. X cap. That means in the reciprocal lattice also we are getting quite similar to simple cubic. Still not understanding? Find B2 bar and find B3 bar. Can you do it? Start. Next BCC, do it fast. And FCC. That means reciprocal lattice of simple cubic is a simple cubic, that you have to show now. That BCC reciprocal lattice is FCC, FCC reciprocal lattice is BCC. That is what you are going to derive. Do it, aram se do it. 2 pi, this is A2 bar cross A3 bar by volume of a real space. Don't copy this formula, try to write yourself, then only you will remember. I hope everybody remember the primitive vectors of real space of BCC, FCC also. I am writing here. I request you find the corresponding reciprocal vectors. I hope if you do this also, B2 A3 cross A1 by volume is A cube. This is a 2 pi A square. Still anyone not understanding? Simply cross product A3 cross A1 Z cap cross X cap Y cap by A cube. This is a 2 pi by A Y cube. So again you got X cap, Y cap, Y cap. Similarly, B3 bar equal to 2 pi by A Z cap. So the reciprocal lattice of a simple cubic is again a simple cubic. That is what you have to write here. The reciprocal lattice of a simple cubic is a simple cubic. Like that, find the reciprocal lattice of BCC and FCC. Make it fast. show that the reciprocal lattice of BCC is FCC and the reciprocal lattice of FCC is BCC. That means if you once you find the reciprocal vectors for BCC, you will get quite similar to FCC. Please check. Only a correction factor, what is that? 2 pi by 2 pi is a scaling factor, by a you will get. Are you doing? Please write there conclusion. How much you got for BCC? B1? B1 equal to, check, 2 pi by a y cap plus z cap. And write the conclusion. Reciprocal lattice of BCC is FCC, reciprocal lattice of FCC is BCC. Find each and everything. Practice, practice. A definite 100% sure question for GATE exam. I think you got B1 bar equal to 2 pi by a y cap plus z cap, quite similar to FCC. B2 bar equal to 2 pi by a z cap plus x cap. If you do the cross product properly, you will get the answer, nothing else, just a small cross product. B3 bar equal to 2 pi by a x cap plus y cap. So all these are similar to the FCC. That's why reciprocal lattice of BCC is FCC. Similarly, write this. Please check how much you got. 2 pi by a, the quite similar to BCC you will get y cap plus z cap minus x cap. All of you got it? And then please write reciprocal lattice of FCC is BCC. So reciprocal lattice of simple cubic is itself, reciprocal of BCC is FCC and vice versa. That means the reciprocal of FCC is BCC. Don't write directly, you must do the cross product, everyone. Next, do these two problems, GATE questions. Primitive vectors of direct lattice are given. They are asking find reciprocal primitive vectors. Yes. What is the first one? B1 bar. How much answer? What you got? 2 pi. Pi is not there. 2 pi into only pi. Minus. You always please write 2. 2 pi. 2 pi. J by 2. Because the 2 pi is a scaling factor. Don't cancel that 2 pi, keep it as it is. I minus 1 by 2 j cap. Please check your answer. B2 bar how much, Naina? 2 pi into j by 1 by 2 j. 2 pi k cap. Next, the second problem. Yes? Can you please tell me what is a B1 bar? Over? Not over. Are you finding the volume first? How to find the volume? Triple dot determinant. Both are gate questions. Do it carefully. Yes, can you please tell me B1 bar? They will check. 2 pi by A I cap plus 8. All of you got this? Come on, do it. Come on, do it. Next, B2 bar, 2 pi by A, 8j cap minus, oh, minus I cap plus 8j. Next, 2 pi by C, which is structure? See HCP structure in your notebook. And the numbers are different, similar to HCP. Maybe he has taken origin somewhere else. Right. Next one. This is the CSIR question. So June 2011. Write down. A 2D crystal, a 2D crystal, a 2D crystal, sorry, a 2D lattice, a 2D lattice of graphene, a 2D lattice of graphene is an arrangement of carbon atoms forming honeycomb lattice, honeycomb, forming honeycomb lattice, HONEYCOMB, comb, honeycomb lattice of lattice spacing A, honeycomb lattice of lattice spacing A, as shown below, full stop. The carbon atoms occupying the vertices, full stop. The Wigner-Zeit cell has an area A 2a square, B root 3a square by 2, C 6 root 3a square, D 3 root 3a square by 2. I will explain this. Next one, try to do it. Now ready. So this is the honeycomb structure. Honeycomb. Okay. So honeycomb structure. Right. Now he is asking what Wigner-Zeit cell. What is Wigner-Zeit cell? Primitive cell. What is primitive cell? Minimum volume unit cell. Now, with the help of your primitive vectors, in the diagram he has given some primitive vectors, if you observe carefully, B1, B2, A1, A2, D1, D2, C1, C2. Please observe the diagram carefully, which primitive vectors are giving minimum area, which are occupying the minimum area. Is it? Yes, sir. These two are same, definitely not that. This is large, so the minimum is this one. So B1, B2 are having a minimum. So everyone, Wigner-Zeit cell means this is the primitive. Primitive means what, ma? Minimum volume. Minimum volume. So in this structure, you have to consider this hexagon where you have B1 and B2. And these two are giving you Wigner-Zeit cell. Is it clear? What? Let me take the diagram here. I am taking a hexagon. Everyone please see, 5 marks, 2 times given, not 1 time. Listen. So this is the structure I am taking. This is the B1 bar and this is the B2 bar. Now I have to write what are B1, B2 vectors first of all. Okay, ready. Okay, what are B1, B2 here? They are not reciprocal lattice vectors. They are what? Direct lattice vectors. Is it okay? Thanks. See the board. So, okay. So, this is the B1, B2. Now, I have to write B1, B2. Now, I am taking this is x-axis and this is the x-axis and this is what? Y-axis. Now, you know the side length is given as AA. A 120, that is why this length is root 3 times A. How to find, you know? Okay? Take a perpendicular and it will be divide, then find this and find this, you will get a root 3A by 2, root 3A by 2, that will be root 3A. So, this is also again root 3A. You have magnitude and I have coordinate axis x and y. I am going to resolve. This is right and up. So, I hope everybody know, one more time listen. This is the hexagon, total angle is what? 120. If this is 120, here and here must be total 60. That is why 30 and this is also. If this is 30, this is also 30. 30, 30, 30, 30. 4 30s are 120. That's good. Now you are ready. Amma, this is 30 degrees. That's why how much? Root 3A cos 30. Root 3A sin 30. So now I am writing my B1 vector. B1 vector is equal to root 3A cos 30. Cos 30. Root 3 by 2 I cap. Say yes or no? Next, root 3A sin 30. I think this can be written as root 3A by 2 common root 3 I cap plus this is my B1 bar. Now let us write B2 bars quite similar to that. Very easy, amma. How it is going? Down and right. So this angle already I told you how much? 30. That's why this is root 3A cos 30 degrees. This is also root 3A sin 30 degrees. Now once you got B2 bar also, B2 bar, root 3A by 2 root 3 I cap. Any trouble? Is it okay? And now what he is asking is, the Wigner-Zeit cell has a area. He is asking Wigner-Zeit cell area. Wigner-Zeit cell means not a reciprocal lattice. Wigner-Zeit cell is what? A real lattice. Okay. The Wigner-Zeit cell in the reciprocal lattice is called first Brillouin zone. He is not asking the area or volume of the Brillouin zone. He is asking area of Wigner-Zeit cell. That's why, what is the area? How to find area? B1 bar cross B2. I hope you know the dabba. Come on. Check what is the answer. on the I cap 0, j cap 0, I cap with j cap with I cap, both products are same, into 2, how much? 2 cancel, do it. So if you multiply these two, this is a 3a square by 2 outside, because root 3a by 2, root 3a by 2. So this is a root 3, 1, root 3 minus 1. 3a square by 2 minus root 3 minus root 3. In minus vachinandamma. Oh, area direction. Okay. So this is how much? 3 root 3 a square. But they have given 3 root 3 a square by 2. Ah. 3a square by 4. Just find the cross product. Request you please read about reciprocal lattice today, and tomorrow we'll go to the X-ray diffraction and evolved sphere. What is evolved sphere? I think you got a 3 root 3 a square by 2. Ready? Ma calculate ready? just a common factor is there, just multiply both 3a square by 4 and after that root 3 1 root 3 minus 1, that is a 3 root 3a square by 2, that is the volume area of the Wigner-Zeit cell. And this is not based on reciprocal lattice. Next question, next year, this was 1 year CSIR, next year. Ready? Still anyone is copying? Next one, again CSIR. Lattice, consider a hexagonal lattice, consider a hexagonal lattice with the basis vectors as shown in the figure, A1 bar and A2 bar as shown in the figure. If lattice spacing is 1, if lattice spacing A equal to 1, if lattice spacing A equal to 1, then the reciprocal lattice vectors are, I am giving the option here. Option A, 4 pi by 3 comma 0 comma minus 2 pi by 3 comma 2 pi by root 3, means B1 bar and B2 bar like that. Option B, 4 pi by 3 comma 0, next 2 pi by 3 comma 2 pi by root 3. Option C, 0 comma 4 pi by 3 comma pi comma 2 pi by root 3. Next option D, 2 pi by 3 comma 2 pi by root 3 comma minus 2 pi comma 2 pi by root 3. Please try to learn how to solve the problems. Theory everywhere you will find, but try to solve the problems. Okay, right. I will start, you please finish it. Now these are the options. We have to find the corresponding reciprocal vectors. If you want to find corresponding reciprocal vector, first you have to write direct lattice vectors. That means A1 and A2. Very simple. See the board. He has given x-axis and y-axis. Observe carefully. He has given A1 bar and A2 bar. Now, could you please tell me without any second thought, A2 bar is nothing but, wait. Ready? So this is A, this is A. How much? This is A, this is A. How much? I told you this is a 120. If you take a perpendicular, root 3 by A2, root 3A by 2, like that. So now come on, say A2 bar equal to how much? Which cap? Because it is along y-axis. But it is having inclination. I hope you understand earlier discussion. This is nothing but what? Good. Now take the resolution and x component, y component and get A1 bar. After that, wait. If you want to find reciprocal lattice vector, you need the third one. Without third one, how you will find? That's why you have to assume third one as a z cap. That is a minimum now. That's why we don't know. They have not given. That's why we are taking a minimum parameter a z cap. So don't forget this. Come on. Let. Without third vector you can't find. This is root 3a cos 30 and this is root 3a sin 30. Please get A1 bar. Once you got A1 bar and A2 bar, assume A3 bar and start finding B1 bar and B2 bar and tell me the answer. After that you have to find area, volume, volume. Oh, volume is easy to find. Once you got A1, A2, A3, find the volume. Don't go for that determinant because it is easy if you observe carefully. A1 bar dot A2 bar cross A3. A2 bar cross A3 easy to find. Get volume A1 bar dot A2 bar cross A3. You will get A1 something, but A2 bar cross A3 is A into root 3A. This is a root 3A square. J cap cross K cap. How much naina? I cap. So maybe A1 you will get something. Volume. Ikkada A1. A1 something. Volume ఎంత naina? 3 root 3 by 2. A cube. They got this volume, please check. What is A1 bar you got, ma? Root 3? I think same. Root 3A by 2. Earlier you got already. Root 3 I cap plus J cap. He has given A is 1. That's why volume is 3 root 3 by 2. And your A1 bar is 3 by 2 I cap plus root 3 by 2 J cap. And your A2 vector is root 3 J cap. And your A3 vector K cap, because he has given parameter is 1. Now please substitute all those things and tell me what is your answer. What is B1 bar and what is a B2 bar? Simply finding the cross product. Do it. You got A1 bar already earlier, A2 bar, A3 bar easy, but he has given A is 1. Just get A1, A2, A3 and find B1, B2. B3 no need to find. If you are not serious, Babu, you won't get. Already you practiced how to find these primitive vectors. Your A1 bar finally I got 3 by 2 I cap plus root 3 by 2 J cap. This is my A1 bar. And A2 bar is here, A3 bar is here, here. And find B1, B2, B3. Yes, how much you got B1? 4 pi by 3A. And A is 1. So that's why what is your answer? Answer, you don't know. You have to go to the next one because they have given two both same. Either A or B. Answer. Find B2. You got B1, correct. 4 pi by 3. I think you got 4 pi by 3 I cap. That's why it is 4 pi by 3 comma 0. But both options are there. I mean A and B. Then go for B2. B2 you have to get either 2 pi by 3 or minus 2 pi by 3. Answer. First option. You will get minus 2 pi by 3 I cap plus 2 pi by root 3 j cap. Do it seriously, otherwise how you will get 5 marks? That's it. And this is the end of some problems from reciprocal lattice. And tomorrow we'll go to the XRD, X-ray diffraction. Before that, some properties of reciprocal lattice we want to derive after just a half an hour. After that, we'll go to X-ray diffraction.